Hello and welcome to another video. Today we have a very interesting subject on our bench. This is a Gigabyte board, a B450M S2H. And why is this so interesting? This board has a really interesting fault that I've never seen like that before. Someone has plugged in a bad use of speed device and overdrawn this. And the very interesting part is this right here. This is a burned track, as we can see right here, going all the way off the perimeter. So there will probably be a short circuit of some kind here, or maybe broken connections somewhere. So I would want to start with some resistance checks. So let's see if anything is directly shorted already. So let's see, 3.3 volts. Has high resistance, 5 VSB. Has high resistance, 12 volts. High resistance and 5 volts. Also high resistance. Let's check the CPU. CPU has high resistance, and let's check the phase to the inductors. Also high resistance. Okay. So none of that is shorted. Let's check for this area around here. So let's see. This inductor this regulator right here doesn't have a short circuit. Let's check these inductors right here. Nothing. High resistance. And also high resistance. So all of that looks fine. That is very good. Let's see. This at the top here should be 5 volt dual. Also has high resistance. So the resistances look to be fine. So, but we will have to dig into this area, whatever is here or under there, and get to the bottom of how deep this damage is. So we will need the microscope definitely for this. So let's have a good look here. So the big track is whatever connects here. So we can see this one is connecting to that regulator and to these 3 pins. So if you want to find out what this track actually is, we can check these 3 pins in order to find out what this track actually is, or like check this resistor right there also. So let's see. I got to be honest, I want to have a good look at whatever is below here. So I probably want to cut this trace at some point. Okay, this track also goes there. Because I want to cut this in order to be able to investigate whatever happened under here. Because everywhere where it's charred, it peels off easily. And all of the other places where it's fine, like this one, it's very hard to peel it. So I would think that we cut it right around here and later restore it. But first, see what we can see when we cut it here, and then see below. So like that, a clean cut. Let's reveal whatever is under here now then. Okay. Okay, and this is this a second? Yeah, this is another layer. Yeah, okay. So this is carbon fiber insulating these 2 layers. And everywhere where it got really hot, it gets like this, where you can just peel it off easily. And we will have to see how far this charring has gotten. So yeah, we have basically 2 big layers that have gotten burned. We have this top layer that also connects with this trace right here. And we have whatever this layer here is. But the good thing is there doesn't seem to be any more connections. This seems to be it for this side. Because here you can clearly see that this part is good, And this black and darker part here just peels off easily, because it has been burned and charred. So yeah, nothing below it as far as it seems. That is very good. That makes it easier for us. Let's peel you back a little bit further here as well, just to see. We can insulate all of this later, but for now I just want to see how far our damage goes. When you have like big physical damage or big burned layers, you always need to assess first how far your damage goes. And this seems to be the limit of it, these two tracks. So this track was definitely burned through. And it might be that this track originally was our problem, and that the one above it just got heated up by this lower trace. That is how it went. So let's check these for resistance then. Let's go onto a ground point and let's check this. And I don't seem to get any resistance reading on it. Yeah. Really high kilo ohms, okay. So that is not shorted. Let's look at this piece here. And this has lower resistance, but it's still kilo ohms, so that should be fine. Let's see. Yeah, and this one. Okay, I might be... Yeah, it should be fine then. Because this is this track, for example. So separating them definitely from each other and checking this right here. We get kilo ohms. That is good. And from the input side, right, this here. Let's see, let me grab it. This also has kilo ohms. So, okay. So, I think we actually don't have another short circuit on our hands anywhere. Let me clean up the area so that we can actually prepare for soldering things together and then insulating them. So, I will be using a lot of IPA in order to just clean out this area. So this actually cleans up very well. I didn't expect that. So we would want to start with getting this piece and this piece back together. Because this is, I think, where our original problem was, that this line got shorted. And that this burned through and separated at that point. So the most optimal right now would be if you would have like copper tape or something like that in order to get both of them joined together. I do not have anything like that on hand. So instead what we are going to use, I will be using some solder braid, because solder braid is also just copper. And we will be bridging these two like this together to restore the trace. And this should be, yes, it is thinner, the diameter, but the width is thicker. Because this is very thin and this is a lot thicker. So this will definitely do. So let's get a good amount of solder onto these first, in order to be able to put the solder braid onto there. So let's flux this up. And now let's see how well it takes solder. So it definitely has a few rough spots that don't like to take solder that much, which is to be expected because it got charred. So let's take the other side as well. Yeah, this one takes solder a lot better, but it should be fine. So let's now get the solder braid into here. So, and now we need to flood this with solder also. Kinda like that. And now we need the tweezers in order to put this properly onto here. Yep, that is good. Now we have actually a proper connection. We can check that also when we go to upper point and a lower point. Yep, you can see one probe goes right there and the other probe goes right there, and we have good connection now. Okay, now comes the point. I could actually, like, if you want to do this any better, you could actually just add a bit more flux. Let's get the tweezers once more. Push down on it a little bit better. And get like a lot of heat into this as well. And here as well. Yeah. Now we have it. This connection is proper now. And this will also withstand a lot of current if needed. Probably won't need a lot of current, this line, whatever this is. But yeah, let's now clean it up. And then comes the important part of insulating this from the next layer so they don't short together. So before we're going to seal this off, I actually want to find out what this trace is. So I will be placing one probe onto here, and I will be going around probing different places in order to find anything where this connects to, because I want to know what kind of trace actually burned up here. We definitely know it's not ground, because we checked resistance against ground and that was high, and I found something. Yeah, there's a MOSFET right there. At this MOSFET right here, we get a connection to there. So let's go into a board view and check where this goes. So in the board view right now, it seems to be VCC3. So connecting to this MOSFET right here, there's a 3.3 volt line. This is the one coming from the 24 pin. So we will check if this is actually the 3.3 volt line then. And let's see, for this regulator, these three here were the input, I think, of this. Or was it this one? Because this, as far as I know, is the input for whatever the top layer was. But I might be... Yeah, I might be mistaken. We might need to check that again. Because I saw that these three are connected, and it looked like they were connected to the trace that was going here. What is this connected on the other side? This is just ground connected on the other side. This is also ground connected, also ground. And this is also VCC3? Interesting. So it might actually be that there needs to be 3.3 volts coming into there in order for this to run. But what is the upper trace then, is the big question. Okay, let's go back to the board and do some measurements. So let's go on to here again. So the trace that we restored, if we check this against the 3.3 volts, yeah, this is 3.3 volts coming from the 24 pin connector. The question is now, what is this then? These are not connected to each other. Yeah, they're not shorted to each other. And what is this then? This is not 3.3. Where are you coming from then? It's coming from there. Okay, so I think this is 5 volts dual. So I'm connected there, and the other connection that I found is right there on this tab. So I think that will be 5 volt dual. Let's check once more in the board view then. So in the board view, we saw that this tab, yeah, this is the tab, 5 volt dual, is connected to also that, yeah, that linear regulator. So the upper layer that we have is 5 volt dual that was cut, and the lower layer is 3.3 volts. So we definitely know now where our voltages go and what they are. and then we can start to repair them and then check if they actually reach all the places where they have to go. But first we now need to insulate that place. So we now know what our lines are here all. So let's start insulating them. You can get UV mask that is like black or is even transparent and stuff like that, but I only have the green one here, so we are going to use the green one. So for UV mask, it's very important to apply it in thin layers. I'm just going to make a blob right next to here. And from this, I will be taking and applying it. The big thing with solder mask like this is you need to apply it in thin layers, because if you apply it in too thick layers, it won't cure properly. So you want to go bit by bit and apply thin layers. Maybe not as thin as I do right now, because we have a big area to cover. But the big problem is if you do it too thick, it won't cure properly, and then will always stay liquid. So if you have a big piece like this right here, you need to spread it out as best as you can. So the first layer is actually on here right now. It's a little bit thick at some points, but I hope that works. I try to still spread it out a little bit, because the good thing is you can stack this solder mask in layers. So what we're going to do, I will try to now cure this part that we have right here right now. And then we will probably go for another layer, or especially on top of the big strip of solder braid that we have, just to be sure that it's properly insulated. So let me get my UV light, and now let's start curing this. So this looks well cured now. So let's check. Yeah, it's a little bit soft still. As you can see, when tapping it, you can see at some points it has some soft spots still. This part is definitely better. This one, as you can see right here, is a little bit soft. So I left it a lot longer now to cure. And now it should be fine. Yeah, it's a lot better now. It's now already a whole track moving with it. Yeah, now it's properly cured. What I want to do, I want to get another layer on top of this thing. Just to be sure that that won't short to anything. I think all of the rest is actually fine. Like the actual copper trace itself is very well covered, and I don't think there will be any problem with that. But the big piece of solder braid I want to cover even more, just to be very sure. So second layer is well applied, and back to curing again. So we should be fine with this layer now. So we should be properly insulated now and don't have a problem with this anymore. So this is our 3.3 volt line that now is insulated. And what we want to do now we want to get our 5 volt dual line back into place where it should be. So we're going to bend everything back where we made the cut. We want this to line up as best as we can, because we are going to use just a solder bridge for these, because that should be fine. And then we're also going to be attaching this small wire here then as well to that. But first, let's connect these two up, and yeah, then go from there. So these are fairly clean. Let's put some flux onto these. And let's get solder on them. So we want it to be close to the edge so that we can actually bridge them properly. Kinda like that. Let's see if we can push down properly on these with tweezers and connect them. Just like that. Now we have a big solder bridge. Have this actually pretty flat. Not completely, but mostly. And now what we need to do, we need to get the insulation off of that, or the solder mask off of that, in order to bridge this again. So I'm just using a sharp razor in order to scratch the point right here. Because if you scratch it, it will take solder way easier. And because you have really bare copper. So let's see if we can now apply solder here. Okay, I cannot connect these. The solder blob would need to be way too big for that. So we're going to be using some wire to bridge over there. Yeah, and of course, after I've tried to use the wire, I now got a bridge in between them. So yeah, let's leave that bridge. I will clean up if that bridge goes away while cleaning up. Then I will have to use wire, but so far it looks fine. So let's clean up all of the solder that is here, all of the flux. So we now got everything connected again. Let's now check for resistances, and let's check for continuity. So first let's check for resistance against ground. So first thing we're going to check is 3.3 volts, and that is the lower one, because we can now check that. I'm checking that in the 24 pin connector, and as you can see, 6 kilo ohms. And now checking the upper pad, which is 5 volt dual, has 2.5 kilo ohms. So that is fine. Let's now check that they aren't shorted to each other. So this upper point right here should be connected to a MOSFET, to a linear regulator, that it is. And it shouldn't be connected to 3.3 volts, but it is. Okay, yeah. So there's still some parts that could short to it. So somewhere I bridge these two together. If I push down on it, I still get a short. So I will have to insulate it even further. But only sometimes. Right now I'm on there again. When I push somewhere here, I get an actual short. But if I lift this up, it's probably shorting somewhere here, something similar to there. But if I lift this up and hold it on, then it's not shorted anymore. Yeah, currently it's lifted up and I don't have a short anymore. But here at the side, I still can get it shorted. So I will have to insulate this part here even more. So yeah, I will do this off screen because this will be a lot of back and forth of insulating and curing. So let me do that first, and when I got it actually cured, I will get you back into here. So it took me actually really long to get this insulated properly. Like, I had to go on with so much solder mask just to be sure that there was nothing touching anymore. And now, when I go to the 5 VSB and to here, the 5 volt dual, we get a beep. But if I now go to the 3.3 volts and try to touch anything, push down on it, nothing anymore. So no matter how much I try it now it's insulated. So now we can actually go over to the next step and start this board actually up and see how it behaves after like so much more time of insulating than I thought this would be easier. But well, there was a lot of exposed copper and a lot of things that got burned, and then yeah, a lot of conductive material that it was open. So yeah, I'll rather be sure here, and let's switch to the overview. So we put a 2600 into here. Let's get a stick of RAM into here, get our power in here. Let's see if we can actually get postcodes out of this PCIe, because on Gigabyte boards you sometimes can actually get that with the postcard. Let's get our speaker and a power button onto here. Well, do we need anything else? I don't think so. Let's hope this doesn't blow up now. Because we checked, nothing is shorted to ground, nothing is shorted to each other anymore. Let's see now. 170 milliamps. That sounds kinda high. Okay, but, well, let's see then. Let's press the power button. 1.8 amps. That looks actually pretty fine. So I get CPU activity because it's definitely getting warm. But nothing happening so far. None of the regulators get hot or anything. The SIO stays cold. So all of this seems fine. Big question is, was the BIOS flashed or not on here? Let's try a different CPU just to be sure. Because I feel like this should be posting by now. Like, it really looks like it wants to post. Let's try a 1600X. A processor that definitely should be supported by this generation of board. Like, no matter the BIOS you have. And let's see now. Let's press the power button. No, it stays at 1.8 amps around there. Okay, let's try without the postcard. If that changes anything for us here. And let's also see if we take the RAM out. I don't get any post beeps. I saw like 2 amps for a very short second, but nothing afterwards. Big question is, it seems that our BIOS isn't initialized because I don't get beeps for like missing RAM. Let's see. There are a few inductors right here to the right. I want to see if any of those have voltage. So let's see. This one, 2.5 volts. Next one, 1.8 volts. This one, 0.9 volts. All of those look fine. This has 3.3 volts. The 5 volts dual looks fine. The 3 VSB should also be there because we get like really far into the post. Yup. CPU is getting decently warm. Let's see, there should be 2.5 volts here. 2.5 volts is present. For the SIO, the voltage should also be present. Right there, 3.3 volts. Okay, so I want to confirm the BIOS on here because this seems to be this seems to have all of the voltages that it needs. I think there has been some work done to this before because the BIOS looks like someone tried to flash it. So let's go under the microscope, take off this BIOS chip and try to flash it. So as we can see right here, this is the main BIOS as it's called, but there is no backup BIOS. There's probably like a pin, like something that indicates where backup BIOS could have been, but there is no backup BIOS on this. Yep. So, well, then it's definitely on the correct orientation, as you can see. There's the arrow in the top left right there, and there's pin 1. But let's get this off. Let's get some flux onto here, get the adapter board, and hot air this off, and flash the content that it's on here. So having taken it off, let's clean up the area, and let's go to the PC and see now for the content of the BIOS. So I've got the BIOS file read out right here. It looks to be fine, to be perfectly honest. But because this is a flashed file already, I won't be saving this. So let's open up a known good one that I've just gotten off of their site. And let's flash that onto here. It looks very similar though. So yeah, let's flash that just to be sure that the BIOS is correct on here. And then we will go from there. So, the BIOS has been flashed. Let's then put the EEPROM back onto the board and hope that that solves our problem. So, chip is on. Let's now go into the overview again. Let's see now, 170 milliamps, and let's press the power button. Still the same, okay. The BIOS was not the cause right here. Yeah, the most obvious things would probably go around the area that the damage occurred in order to find out if anything there is still missing, because this is obviously not booting. There's obviously something wrong still here. Something is missing. So let's hop under the microscope and I will have a close investigation. If I find something, I'll get you back in here. So this took me all day. I legit sat down all day long trying to figure out stuff with this board. And I've gone about changing different stuff, like I changed some crystals, did some soldering, I took off the audio chip and the Ethernet chip off of this board, but I think I found the root cause. You see right here, I have a resistor soldered right here, and this is close to the BIOS chip. Let me get that resistor desoldered, and I will show you why I did that. Desoldering that resistor. Let's clean this up. So have a good look what we have here. We have the BIOS chip right here, and then we have arrays of resistors, and these are 22 ohm resistors, as you can see right here. And each of these lines is a single 22 ohm resistor. If you don't know what this is just 4 resistors with the same value, in this case 22 ohm, which means 22 ohms and zeros after that, so 22 ohms. And this is just 4 of them in a row. And each of these is 22 ohms except this one. And even if you go onto the top here, you don't get 22 ohms. You can see this one is broken. This resistor network has broken here. And this one is still fine. And I'm pretty sure that this one up top is not used. As you can see, no traces there. So this is a spare 22 ohm resistor that we could use. Let's have a look in the board view just to be sure that that resistor network is actually free on that spot. So in the board view right here, we see this 22 ohm resistor network and pin 1 and pin 2 not being occupied. And the other ones is chip select for the BIOS chip. That where the 22 ohm resistor has blown. So how did I find this? Basically just spending hours and checking everything. I got to be honest, I wish I could tell you that I systematically found this and searched after something, but I did not. I was at a point where I didn't know what was happening with this board. And you could say, yeah, this board got stuck without accessing the BIOS. And that's also why I flashed the BIOS at one point. But I would have never been able to tell you that the chip select of the BIOS chip wasn't high. And that is the problem of this board. I could have never told you that. So you saw me before. I put a big resistor with the classical through-hole resistor onto there, but I've realized while I'm starting the video that there's a spare 22 ohm resistor up there that we can use, and yeah. So let's just bridge them. I need a little bit of a finer solder tip to do this properly. So now we have these two connected on both sides. And let's clean that up and we can take measurements once more. So let's see here. After having now soldered it on, if we now take this point right here and we take this point right there, we now get 22 ohms. As if they have planned to have a spare resistor for that chip select. I cannot believe how this went. So let's go into the overview and let's see this thing boot. Oh yeah, and before that, I want to show you, this is where the Ethernet chip was. This is this fella right here that I've taken off just to be sure that that isn't a problem. And down here is where the audio chip is supposed to sit, which I also taken off just to be sure that these aren't putting a fault onto the board. So if the board works now, I will have to put those two back on as well. So time has come to try this board now. I've built it up. There's a GPU, a CPU in here. We have RAM. And let's see now. Pushing the power button. And it's not getting stuck anymore. 2.3 amps. And here we are. 3 amps. 4 amps. Let's see if we get a post screen now. 3 amps again. And there's a post screen. I cannot believe it. Let's see, I just had some trouble with getting 2 sticks of RAM working in here. I'm just going to plug it in and out a couple of times just to get this working. Yeah, and now it's also booting with both sticks, as you can see, 4.2, 3.2. Yep. Let's see, let's get an actual BIOS splash screen into here. So board restarting, there's the Gigabyte logo. Let's see a BIOS. Another restart. And there's the BIOS configuration that had been reset. Oh, this board is on. I cannot believe that. It is actually working. Oh man, that was so lucky of me to find that at some point. I was spending so much time with so many different things on this board. I still have to put back the Ethernet controller and the audio controller, go into Windows and test them. But this already is a huge win that this now works. And that there all of a sudden was a 22 ohm resistor just next to it. Or like that the array has one more that wasn't used that I can use for that. So yeah, what I can say, I had every single voltage on this board. I went ahead, checked all of the voltages, all of the power good signals, all of those stuff, checked multiple oscillations and so on and so forth, and nothing looked wrong. Everything looked right. And that's a good reason why to have a good look at the BIOS then. And the BIOS itself was good. I already went ahead there and tried to flash it because I thought there was something wrong with it. But looking for those 22 ohm resistors, like that resistor network, like I didn't think that far to do that. But yeah, at some point I did. All of a sudden I thought about, yeah, let's just check them because I have nothing to do anymore anyways. And yeah, that was actually it. And that actually fixed the board now. And I want to show you something. Have a good look with me right now here. It's probably hard to see. This says the 23rd of September 2024. And this is a B450 Gigabyte S2H. And if we open up this video, you won't have audio because I cut the audio. I'm only recording my own one. But this is me 1 year, almost exactly 1 year ago, fixing this board. The day that I'm recording this is the 16th of September 2025. And I have this thing in my hand the first time, 2024, the 23rd of September. And I didn't want to throw it away because I wanted to fix this one. I wanted to figure out what is wrong with this. And this video goes on for 50 minutes. If I can smaller this window, you can see right there 53 minutes of recording. And you can see the power supply that I'm still using right here. This is the 100 amp 1200 watt power supply, server style power supply that I'm still using to provide 12 watts. And this is the old current meter that I was using. And you can see me also here going over different things and trying to figure out what is wrong with this board and my old current measurement meter device. And yeah, many different things that I've already tried here. And I was actually here. What? I didn't know that. Did I destroy that? No way. Was I the one who destroyed that? No way. I cannot believe that. 1 year ago I looked at this. I cannot believe. This was actually broken. There was actually something there. And I didn't know that I checked that because it's been a year. I have something stuck in there that looked suspicious to me. And I tried to get that out. And look right there. The resistor is broken. I cannot believe that. Probably I broke this resistor. There might have been something wrong with this, but it might be that I just broke that resistor right there. I cannot believe this. Like, I wanted to show you this old video, but I didn't expect to find this. I don't remember any of this. It's been a year. I've fixed like so many different boards in between there. But I can't believe I have been there. I've sabotaged myself. That is... Do I even check that now? I cannot believe this. Am I going to check this now and I just forgot? No, really? Yeah, I checked these. 22 ohms, you can see. And here. I checked that. You can see it so well happened right here. I checked it and it first wasn't working, and then I put this contact back. I pushed it back. Have a good look. There's the open contact. You cannot see anything. And then I push this one back. Look at this. I push it back and make contact. I cannot believe what happened on this board. This just turned ridiculous. So I actually checked. I even double checked this one and I got a reading. I cannot believe this. Wow. Pah. That is quite something, yeah. And then I just proceed to flash the BIOS, as you can see right here. And yeah, start to do different things here. And probably that resistor cracked under the heat fully. I probably destroyed that resistor. I cannot believe this. Well then. Well, almost a year later. Who could have imagined that? What a twist. I cannot believe this. I just wanted to show you the video because it's been a year that this thing was on my bench and was laying around at my place, and I wanted to fix it at some point. And I cannot believe that that fault with the 22 ohm resistor was actually caused by myself. You cannot even trust yourself. I myself have sabotaged me. That is so ridiculous. That is such a good way of showing why previous repair attempts suck. That issue wasn't there at the beginning. That issue was caused by me. And just like fixing someone else's mistakes, fixing your own ones like that, I cannot believe that. Well then, I will be spending the rest of my evening putting back the audio controller and the Ethernet controller, cursing myself for what I've done to myself, and yeah, being done with this board after that. Cannot believe this. I hope you enjoyed the video. I hope you learned something out of that, got some entertainment out of that. All of my tools, as always, are linked in the video description. If you want to get one of these measurement tools for the amperage and for the boot, email me. I sell them, the big version in black with the big screen that you can service yourself because everything is labeled on the board. And yeah, this was Mainboard Medic. Thank you very much for watching and goodbye. Spent a little bit more time on it and got the Ethernet and the audio working. Both chips are back on.